Okay, we have Project Euler problem 18 here, maximum path sum 1. By starting at the top of the triangle below and moving to adjacent numbers on the row below, the maximum total from top to bottom is 23, 3, 7, 4, 9. That is 3 plus 7 is 4 plus 9, 23. Find the maximum total from top to bottom of the triangle below. So get this thing. Ooh. Note, as there are only 16,384 routes, it is possible to solve this problem by trying every route. However, problem 67 is the same challenge, but with the triangle containing 100 rows. It cannot be solved by brute force and requires a clever method. Sideways smiley face. So there's the answer. We're going to do this in C. Now, I had a little bit of issue with this because from the way they're wording the problem and the way they're laying it out here, you want to think it's just you read the row below the current one and get the maximum of the two adjacent directly below the number. But that doesn't really solve this triangle. That solves this one, it gives 23. But if you solve this triangle just by taking like the larger of these two from 75 to 95, and then the larger of these two, and then the larger of these two, so on and so forth, doing this, you're going to get the wrong answer. What they actually want is the maximum path, say, from the top to the bottom. So trying it with this top triangle, the maximum path is this, but you get there by trying, 3, 7, 2, 8. So you get this kind of left-facing path here. And then 3, 7, 4, 5 is another path. 3, 7, 4, 9 is the maximum for this. And then the right path, 3, 4, 6, 3. So the maximum path in that is this. And you want to kind of do it from that perspective, not taking the two adjacent, but taking a maximum path through the triangle. So that's what I'm going to do in this program that I'm going to write here. I had issues until I did that, and then we ended up getting the right answer. Now, other people online take this from a bottom-up approach. It looked like they calculate, whatever the maximum pairs say are between the bottom row and the one above, and then they move up through the triangle. But I wanted to read this in from a file, so it would be a little bit easier from a file or standard input and read top down as we're reading it in, not starting from the bottom. And now we're here, we're starting from the top and going to the bottom. So that's what I'm gonna be doing, top down perspective in C. So let's get to it. Okay, got the program here, got the, the shell open here in the Emacs, got the triangle nums file, which I filled out. I think it's still set for problem 67. So let me get this copied in. So we'll select all and just paste that bad boy in there. So that's the, the triangle from the problem. Now what I want to do is try to read these things into rows and take, we get the first row and then we're going to read the second row in. We're going to get a maximum. We're going to read the next row in. We're going to get a maximum, so on and so forth. So to do that in C, I'm going to have to, define how big we want our rows to be. Probably going to use an array, an integer array or two. One for the current row and one for the previous row that we're going to compare to and get maximums from to find the maximum path. So the maximum amount of numbers in a row here is what? 1, 2, 3, 6, 9, 12, 15. So we'll make them 15 long, 15 large. Include, we write it like this, include. The standard IO header, that'll allow us to use printf, and that'll also allow us to read from a file, since these numbers are in the triangle nums file here in our current directory. I'm gonna have a couple global variables. I'm just gonna put global vars to hold our number arrays, because I'm gonna use a second function to read and pass our arrays through when we want to process the current row that we're on, which you'll see in a bit. But I'm gonna have a couple global arrays for that. So I'm gonna have integer arrays. We're gonna have a current row and last row. So I'll just do int last row. Let's make it 15 long, which is how long it was. I'm gonna initialize it all to 0. And we're gonna do the same thing for a current row variable, 15 in length, that we're gonna initialize to 0. And then we'll have our main, we'll have our other function, but I'm gonna do main first, so I'll leave a little bit of room here. Main, I'm not gonna pass anything to it. And we'll just, have the regular return 0 here. We're gonna do this. So since I'm reading from a file, I'm at least gonna need something to read the file with. So I'm gonna use a file pointer. File FP, I think, is standard. So we're just gonna use that for our file pointer. A couple other things we're going to need. I'm going to try to keep track of where we are within the current row that we're at. So I need something like a counter, an index to see which number inside of the row we're at I'm going to use. So for that, I'm going to have an integer. We also need something for our sum at the end. Our sum isn't too high, so we can use ints for all these. I guess we'll have a max sum, or I didn't want to do that. I don't know what key I hit there. Max sum or final answer or something. I'm going to call it max sum. I'll just initialize it. Why not? I'm going to have a temporary number variable that'll hold which number we're on within the row. So I'm just going to call it temp for brevity's sake. Then I'm also going to have the index I was talking about, which basically a counter of how many numbers are in the row that we're at, just to use for a loop later when we process the row that we're in. So I'm going to call it index or row index or something, say. I'll just make it row index. And eventually I think I needed another for loop counter, so we'll use it later. I'm just going to call it I, a regular for loop counter. I'm going to read the file that we have. I'm going to read it as character data, stream data. So I'm going to need character variable. I'll just call it C for character. And then we have our file pointer. I think that's all we're going to need for the main, our main function here. So that's all I'm going to use. So if we want to read from the file, I'm going to open it. So open file for reading, which will be going to say fp equals file open. So fopen command. What file is it? It's triangle nums. The nice thing about Linux is that you don't really need to have file extensions. They're pretty great like that. So we can just call it this, triangle nums. We're going to open it for reading, so R. And as we read it, we can do, I guess, a while loop I'll do. Be kind of the easiest way. So while C equals, is it file get C? Yeah. While C is F get C, so get character from a file. And we're using the file pointer. That's the file we're getting this from, the triangle nums file pointer. So while this is not end of file, so while we're still reading the file, we're not at the end of it, we need to process what we're reading into. So there are only a few cases here we need to really consider for this problem, and that is if we're at a number, if we're in between numbers, which will be a space, a character, space, ASCII style, and if we're at the end of a row and going to the next row, which is a new line, or end of file, but that's the fourth case we're already handling. So a number in between a number at the end of a row. So if we're at the end of the line, if the C is a new line, we're going to have one case for that. I'll just put this here. I'll put an else if we are in between the numbers, which means we're at a space. Else we're in the numbers, so being if we're at the number, so we'll start with 75. We want to read it in. We need to store that number. I'm going to use temp to store it, and you could use A2I, I guess, or you could read in maybe a word at a time instead of a single byte or a single character like I'm doing here. But I'm going to read in, one character at a time, which means it'll read in one digit at a time. And as these are all, well, other than like 0, 4, stuff like that, these are going to be 2-digit numbers. So how do we get a 2-digit number into our stuff here? Well, first, since we initialize temp to 0, we can do it like this in 2 steps. We can multiply temp by itself with 10. Temp equals temp multiplied by 10, rather. And that'll, fill out our tens place here. So I know it starts at 0, which it'll be 0. And then what we're going to do is add the character that we read. So we're going to add C subtracting the ASCII character 0. And this will convert the ASCII character to an integer, kind of like A2I, that function from the standard library. So what this is going to do, we're going to read in the first character, it's a 7, temp is 0, so multiplied by 10 is 0, and then we're going to add the 7 minus, apostrophe 0, or quote 0 quote, which is also, I think, 48 in ASCII, but that'll just convert it to a number. The number 7, well, in ASCII, the numbers are arranged from 48 to 57, from 0 to 9. So the number 7 would be 55, I guess, because it's in linear order. So if you take the ASCII character equivalent for 7, which I think is 55, you subtract this 0, or, well, 48, from that. 55 minus 48 is 7, so you'll get the integer 7. So we'll put that into temp. And we're good to go. We have the number pretty much. As we read the next character, we'll also add that to temp. So temp will contain whatever number we're currently on. when we get to the 5, we're gonna, you know, temp will already be, well, temp will be 7. So the next character we read on the second read through will be a 5. Temp will be multiplied by 10. It'll be 70, and then we're gonna add the 5. So temp will be 75. So that's how, you know, we can get double digit numbers. We could get 3 or 4 digit, whatever digit numbers that'll fit into an integer length here. So that's all right. So we got that case figured out. It's pretty simple. Now we need to go to the next case. If we're between numbers, but we're not at the end of the line or end of the file, we're at a space character. And what we're going to do here is add to the current row of numbers our number. So I'm going to use the index here as a counter. I could have called it counter, but I'll just call it row index. But this will equal our temp number, and then we're going to reset temp for the next number. We're also going to increase our row index. We're going to increment it. Sometimes I read my stuff backwards, like here, I'm putting comments in backwards, because I found that it helps. If you read your code backwards, it helps you get mistakes more easily. Since we're used to, well, at least regular English speakers, right? We're used to reading left to right, top to bottom. If you kind of read it right to left, bottom to top, you're more likely to catch mistakes or errors in your judgments and things. It's pretty interesting, actually. I don't know where I read that, but I've been trying to practice that more, especially when coding, because it helps cut down on bugs a large portion of the time. Although trying to talk at the same time you're coding does not, and introduces a lot more bugs because your mind's in a couple places at once. But anyway, I digress. This is all we're going to need to do for our in-between numbers case here. So our third case that we need to handle is when we're at the end of the line, the end of the row that we're in. And what do we want to do here? Well, we want to process our current row and try to get the maximum path that we're at so far. We want to compute that, and then go from there. So we're going to compute the maximum path to start off, which is, you know, nothing. We just have one number. But when we get to row 2, we want to get the maximum path from the first row. So which will be 95 in this case. But when we get down to here, maybe it's different. Maybe we could have done all the way right and it would be better, which it seems like that might be better than 75, 95, 17. Adding 64 and 82 would be higher, right? So that would be the maximum path from here, I think. So we want to, you know, compute that. So how do we do that? Well, when we reach the end of the row, I'm going to add the current temp to our row again. Or well, yeah, because we're not at a space, but we are at the end of the line. We still need to get the last number that we entered. So similar to the space character case, I'm going to add in temp to our current row. But in this case, I'm going to set, I'm going to reset our row index at the end of this, at the end of our processing to reset for the next row. All right, add our number in. So after we do that, we're going to reset temp. So how do we process the current row that we got and put it into or compare to the last row that we got? Well, I'm going to use a separate function for that solely because we're going to have to do it again after this while loop because we'll reach end of file. We'll basically have to do this same code, and I didn't write it to where I didn't have duplicate code when I first did this, so I'm going to keep it like how I did it then. I'm not going to optimize this right now because I don't feel like debugging more than I already did. But anyway, I'm going to use another function for this. I'm just going to call it process row. And to cut down on more variables needed, I'm going to pass in the row index as a counter. Or I could initialize a row counter, or I could make row index global. I don't know. It doesn't really matter. I could make row index global and it wouldn't matter, but I did it like this earlier. So we're going to do this now, which last is an array, so I'll put that there so I remember. And that's all we have to do for this. So I'm going to process the current row of numbers that we're on. So if we're on, row or 2 or 3, we're going to go through these, and then we're going to add up. Basically, we're going to add up the numbers within the current row that we're on to the last row that we got, which at the end of this, I'm going to copy current to last. But we're going to go through the numbers in the current row. We're going to add them up to the last row. We're going to see what the maximums are, and then we're going to basically copy into the last row. And what this will do at the end is kind of collapse our triangle by one row. It'll basically move we're going to add up 75 to 95 and 75 to 64, say, and that'll, as we move on to the next row, that'll kind of collapse the triangle inward on itself. So we won't have to go through, a full path here and then 75, full path here, and then do this, because that's really slow, a brute force attempt. We're going to collapse it one row at a time, and it'll end up really fast. This program completes pretty fast when it's ended. But anyway, process rows, let's get to that. Int process rows. And I'm passing, I'll just say counter or count. I'm passing an integer to it in the row index. So we'll have that. Another index, because I didn't want to pass the row index, or I'm passing the row index, but I need another one for this, and you'll see why in a second. But I'm also going to have a couple of things called left and right, and these we're going to say are the parents of the current row we're on comparing to the row before we got. So this doesn't make much sense the first time we're going through because we only have one number, but on subsequent rows we want to compare the current one to the last one we're on. And if we're in the middle of the row, say here at 47, if we're processing this number, the row before it, in the triangle form, if you can, imagine the triangle, we'll have two parents, 95 and 64, as opposed to 17 on the left, on the row above, it's not going to have anything. So that doesn't make sense. Let's play the browser again. So like here, when we get to the third row, 47, we have one to the left and one to the right, 95, 64. We want to compare to both of those. And that's what we're going to use our left and right variables for. If we're on 17, we don't have anything to the left. We only really need to compare to 95 to get a possible path through the triangle. But if we're on the middle, we can have a path going this way or this way, this way, this way. It has multiple parents. If you're all the way on the right, then we only have one parent, up here as well. So those will be the few cases that we'll have in our loop here as we're processing the current row. So okay, we got these variables figured out. I think that's all we need here. Yes, so let's loop through our current row. We'll take an index, make it equal to 0, less than or equal, have it go up to whatever count we passed in, and we'll increment it. So our three cases that I just briefly mentioned there are when we're at the entire left, the leftmost, column, or the first column you're taking in the row, basically the left side of the triangle, anything in the middle that can have multiple parents in its previous row, and then the right side of the triangle. So we'll have three cases there. And the left and right are pretty similar, but I just marked them off as separate cases. So what that is in code and conditional logic is, if our index is 0, if we're just on the beginning of the row here, or on the leftmost side, the only parent it has is the leftmost side of the row above. So that's the only thing we have to compare it to or add it to. And then we have the right side of the row, which is else if our index is equal to the count. So we're at the end of the current row of numbers we're in. Else we're in the middle. So I have an else case here, final case. All right, so if we're on the left side of the row, or I'll just put like the start, I guess, start of row. So if we're in the leftmost side of the row, we need to take basically the same position in the row previous, which will also be 0. So if we're on 17, we'll need to compare to 95. That's the only thing we can compare to because it has no other parent. What I'm going to do is add the previous row that we computed before this point to our current row that we're computing. Since 95 is the only parent for 17, we're adding 17 to 95. And on the rightmost side, we'd be adding 64 to 82. In the middle, we're going to compare to these two parents to get the maximum path. And whichever one is greater, either 95 plus 47 or 64 plus 47, whichever one is greater is the one we're going to use to go forward, because that'll be the maximum path from that point. So that's what we're going to do here. So I'm going to add these things into our current row. Our current row at this index point, we're going to add up the index from the last row. The same thing here for the rightmost, except it's a little bit different because if we're on, say, the third row, we have 3 numbers. The second row is only 2 numbers. But so going from the rightmost point in the current row to the one in the last row, you'll be subtracting 1. So current row index will be added to last row index minus 1. Okay, otherwise we're in the middle of the row, so let's compare to the parents, which will be, left and right hand parents. So if we're at 47, the left hand would be 95, right hand would be 64. So let's set those up just to make this a little bit easier to read. We'll have left will be the comparison to the left hand parent. So left will equal the current row plus current row index we're at. In this case, if we're in the middle of the row, plus the last row of index, would be the same index, yeah. And then right would be current row index Can't type at all today. Plus last row index, is it +1 or is it -1? No, right would be the index. Left row would be -1. Okay. I'm glad I write notes for these things. All right, so what this is saying is, say we're at 47 here. Our index that we're counting up to, you know, is 3 for this row. So our current index, if we're at this point, is 2 because we're in the middle. If we want to compare it to the left-hand parent above, that would be in index 1. So we have to add up, you know, left would be index -1. Position 2, this is left hand, this is only 1, so 2 minus 1. The right hand would be position 2. Since we're at position 2, we just take the same index. You know what I should do is, so I don't have black bars this whole video, that's probably annoying. Let's maximize this. That probably looks a bit better. I should have done that earlier. That's okay. We want to compare which one of these two is greater. So what do we want to add into our current row that we're doing? We want to add in which one is greater. So I'm going to see if left is greater than right. So we're going to use our ternary operator, which I always forget exists because at work and day jobs and stuff, I don't use something that has a ternary operator. So I really like when we got it because it concises things a hell of a lot. It's nice. I don't think concises is a word, but it is now. So is left greater than right? If so, we're going to go with the left. If not, we're going to go with the right. Or if they're equal, we'll go with the right, and it won't matter because they'll be equal. So that makes that, you know, pretty trivial, which is nice, and that adds to our current index. So that's really all we need to do to add up and compare to the last row compared to the current row, that whatever we're computing in here. So after we do all that, we have our current index filled out, or our current row filled out rather. And then what we're going to do is copy the current row to the last row in order to condense our triangle here. So after we compare and we've added stuff up, we're going to move current into last since we made them the same, and we'll move these numbers added to this into this, and then we'll read again. So basically we're just going to condense our triangle one row at a time after we move it into last each time. Okay, so how do we copy? You can use something like memcopy if you want to include, you know, the string library, I think is what needs that. Or you can just use a for loop. We can use our index again. Index is 0. Index less than or equal to count, and index ++. You could probably put this inside of here as the last position in here instead of doing it separately like this, but you know, oh well. I think this maybe makes a little bit more sense conceptually. Helps compartmentalize my ideas. So we want to copy it after we're done processing it. So all we need to do is move into our last row, the values in the current row, and that will copy it over. So, and this will work starting off because I initialize them both to 0. They'll just have 15 zeros. But after this, the last row and the current row will be 75. Then, you know, fill out the current row 95, 64. We'll add them up to 75, and then we'll put those into the last row, and so on and so forth. That is all we need to do this problem. So after we got all that, all we need to do, since we were processing all the rows here, we got all these cases figured out. The only case we haven't handled is end of file, because this isn't a new line, this isn't a space, this is an end of file. But basically we just need to handle it the same way we do a new line, except we don't really need to worry about temp because we're not going to read any more numbers. But we can really just do all this here again. All right, copy that in. So row index equals temp because we do need to process the last number we got. And then process the row. We don't need to worry about temp though. We don't really need to worry about row index, or well, we don't need to reset row index because we want to process the last row. So we did that. Okay. So after we do that, what we're going to have at this point after end of file is we're going to have a final row after we process our current into our last. So last row will contain basically the possible maximum paths up until this point for each position in the row. So what we want to do is take the max of all the numbers that we end up with in our final row, and that will be the maximum path throughout the whole triangle. Sorry if that didn't make sense. I know I probably say that at least once every time I do one of these, but I'm not the best explaining type of person. But this is why we needed a separate index from row index, because we're going to compare to it to loop through our thing here. What we could also do is maybe like size of the array, or just put a 15 since we're only comparing to 15, but I don't know. I wrote it like this, so I'm going to do it like this. I++ All right, so all we're gonna do is compare and get the max. So since we initialized our max sum to 0, we can, you know, use it in our comparisons here right off. If max sum is less than our last row I, then max sum can equal last row I. Or if last row is greater than max sum. But yeah, if it's less than whatever number we're at, we're going to make it equal. So that gets the maximum in the final row. I'll just call it like that. Okay, but anyway, we got the max sum. Now we should be done with the problem. We should be done now. Hopefully it's correct. We are done now. I don't know. I just thought that was kind of fun. Let's do n. Let's do max sum. It's a integer, so we'll put the %d. We'll put another new line. Max sum. Okay, and we should be good. That's all we're gonna need to do. If you want to be nice, good little coders and clean up your mess if you made one, which we want to do. We don't want to leave that file hanging around in memory, taking up needed resources by other things. So let's close it, clean up, and then we'll end the program, return 0. So to signify a successful end, that should be all we need to do. Let me go back to my terminal. I'm using Clang, so we'll do Clang 18. Let's make sure I save this. No changes, okay. Okay, control reaches end non-void. So obviously I typed something wrong, which is great. And this is invalid because it's implicit, which is not great. So what did I not type right? 28.1, this. Oh. I don't want it to return anything. I just press int because I have it. I typed int. Implicit declaration is invalid. Process rows. Process row. There we go. And after working for a couple years, you actually kind of read debug messages a lot clearer. You kind of know what you did wrong faster, so that's always nice. Got a lot more debugging experience now. Anyway, a.out basically compiles instantly, runs instantly. Max sum 10,074, which is the correct answer. 10,074. Oof. So that's all we need to do for that, pretty much. So problem 67, the exact same thing. You just get a different file which has 100 rows. So I'm going to show that right quick just because it's the exact same problem. We don't have to do it later, we can do it now. Because programmers are lazy and that's what we're good at being. So let's go back to our triangle nums thing here. Let's get rid of that, and do I have the numbers copied somewhere? Let's see, into here. Okay, 100 rows. So the only thing that we would have to deal with is the fact that these numbers might be bigger, but I think, no, the answer is still fits within an integer space, but these rows are definitely a lot bigger than 15. I think the maximum row size here for 100 is somewhere around like 98 maybe. I'm just gonna put 100 for a nice even number. So give these 100 rows of space and they'll be all right. But other than that, we don't need to change anything about this problem, so that's really awesome. Do need to recompile. 5139, that is not the right answer because I've done this before. Is there anything at the bottom? There is an extra space there. I don't think that would change anything. Would that change anything? That would change everything. Okay, so if you copy it with an extra space, keep in mind that changes your problem, your answer. Because I do not handle things like an extra space because I reset things here and that's not good. So anyway, that's probably what happened. But 7273 is the answer to problem 67. As you can see, the exact same algorithm, exact same things, just you know, increase the size of your arrays to hold bigger numbers, or use a language that isn't C that holds arbitrarily large numbers. But yeah, that's how you do problem 18 and problem 67. Hope you enjoyed. Next time we'll go to problem 19, counting Sundays. So I guess some date math or manipulations there sounds like, or you know, a Bono song, Sunday Bloody Sunday. I don't know, but it's U2, not Bono specifically. But anyway, yeah. Thanks for watching. Hope you all enjoyed. Catch you guys later.